What's up, guys? It's LeetCoder. This is LeetCode 217 contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Example 1, nums is equal to 1, 2, 3, and 1. And because 1 is in the array twice, we return true. Example 2, nums is equal to 1, 2, 3, 4. And there are no duplicates, so we return false. Okay, let's think of a brute force solution to this. So here is our first array. And all we have to do is check every element with every other element. So we check 1 and 2, 1 and 3, 1 and 1, and oh, okay, we found a duplicate, so we return true. Now let's do example 2. Again, we check 1 and 2, 1 and 3, 1 and 4, no duplicates found. So we go 2 and 3, 2 and 4, no duplicates found, 3 and 4, no duplicates found, so we return false. In terms of time complexity, this is going to be O of n squared, because we're checking every element with every other element. In terms of space complexity, this is O of 1 because we're not storing anything. Okay, now how do we improve this? This is similar to the two-sum problem that we did earlier. We can trade some space complexity for time complexity. What we want to do is have our time complexity be O of n and our space complexity be O of n. And the way to do that is to think about what kind of data structure can we use? What kind of data structure has an O of 1 access time? And again, if you've watched the two-sum video that I did, the answer is a dictionary or a hash map, whatever you want to call it. Now in this case, we can be even fancier and we can use a data structure called a set, which is kind of a specific case of a hash. So let's go through this algorithm again. So let's do 1, 2, 3, 1. And this time we're going to be using a set. And all we do is we go through the array, start off on 1, we add it to the set. Then we go to 2 and we check, is 2 in the set? Nope. Okay. Add it to the set. We go to 3, we check, is 3 in the set? Nope. So we add it to the set. We go to 1. Oh, 1 is in the set, and therefore we return true. And sets have an O of 1 access time for checking if something is in the set or not. And that is because sets are implemented using hashes, which are O of 1. Now, if we think about our other example where this is actually a 4, we'll get to the very end of the loop and we'll check is 4 in the set. It's not, so we add it. And oh, we finished our loop here and we return false. So again, we traded some time complexity for some space complexity. We're only going through this array once, that's O of n, and restoring n elements, worst case. And that's also O of n. And that's really all there is to it. Now, before we get to the code, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. With that said, let's get to the code. Okay, first thing we want to do is define our set here. We'll call it scene to represent if we've seen the number or not. Then we're going to go through for each element in nums, check if num is in scene, and if it is, we return true immediately. And this will help us avoid a bunch of extra processing. Otherwise, we add num to the set. And if we end the loop and we haven't found a duplicate, we just return false. And that's it. So let's run the code. Boom. And normally I would go through examples just to make sure that it works, but this is a pretty straightforward algorithm. So let's just submit here. And boom, we did it. Again, the trick in this problem is to know your data structures, first of all. So know that hashes and sets have O of 1 access time, usually. And also think about trading time complexity for space complexity when possible. And that's it. Let me know down in the comments if there's any problem you'd like to see next. And make sure to hit that like and subscribe button. See you next time.